Want to know how to read server stress tests? Stay tuned to watch the benchmarks and their step-by-step interpretation right now. For the benchmarks, we use an old computer, an HP Pavilion with an i7-6500U processor, 32 GB of RAM, and a fast SSD drive. As the operating system, we run the recent Rocky Linux 10.2, Red Hat compatible and specially focused on enterprise server use. We boot the system. If you haven't installed it yet, check out the card video and come back. Then the default user prompt appears. Enter the GNOME desktop environment. Press Super to access the dock app launcher and run the terminal. We enlarge the font size. Despite having installed the server with GUI mode, using the RPM QA command, we can see that neither HTTPD nor Nginx is present. With the sysventil status command, we verify Cockpit, which is a web interface to manage Linux servers, and we find it is active. To check the correct operation of Cockpit, we open Firefox. Then, we enter localhost with the 990 port in the navigation URL. It will show the login screen. We enter our username and password. The web interface will load immediately. We increase the size. On the left side, we can find the services option in System. Clicking it will display all enabled and disabled system services. In the Tools section, always on the left, we can see the applications. We return to services to find HTTPD and Nginx, but not. We return to the terminal and execute the sudo dnf install nginx command to install the web server, which is light and fast. After the installation process is finished, we proceed to enable the service. We do it with the sudo systempl enable now Nginx. With the firewall-cmd permanent add service OGTTP command, we open the HTTP port permanently to allow normal web traffic in. Again, with the firewall-cmd permanent add service HTTPS command, we enable HTTPS, then firewall-cmd reload applies changes. We return to Cockpit and search for Nginx. Now the server finds it enabled and running. We enter to see details and go back. It displays a message stating that the web console is running with limited access. We enable administrative access with a password. From another PC we run RHEL to test with minimal threads and connections. This measures the initial response speed of localhost. Then, here we increase the load to moderate levels to evaluate the behavior of the server with multiple concurrent requests. Now we test with more threads and concurrent connections to analyze the server performance under a more demanding user traffic. This high load test increases concurrency, which raises latency and generates the first network connection timeout errors now. The final stress test pushes the server to its absolute limit to find its breaking point and measure connection failure rates. The left section shows the glossary with key metrics such as latency, requests per thread, transfer rate, and socket errors. Moving to the configuration column, we see the 5 load levels reflected, scaling up from few threads to an extreme test here. We continue reading the latency zone, which details vertically how response times rise up from milliseconds to full seconds. Following the workflow, we read the requests per thread section, proving that individual performance drops as connections grow. The consecutive column displays the global results, where the total volume of successful requests stabilizes near the limit. We now pass to the vertical block of socket errors, which visually warns how extreme saturation generates dozens of failures. Moving to the right, we read the main graph, which visually contrasts the increase in latency against the total request count. In that same graph, we observe the test data below, detailing the simultaneous increase of users on the horizontal map axis. Finally, we observed the key conclusions box, directly pointing out the exact point of web saturation and speed degradation. We start a longer test with low load to observe the stability of the server and the average rate of data transfer over time. We raise the demand while keeping the extended time to see how the data stream reacts to an intermediate volume of web users. This prolonged test with high concurrency evaluates system endurance during peak traffic times and measures service regularity. We increase the intensity over a long interval, which elevates response, delay, and generates packet loss due to saturation. We conclude with a sustained stress test to saturate the bandwidth. With this, we force the system to gather drop errors here. The left section details the explanatory glossary with key metrics to evaluate the sustained performance of the local machine. Moving to the configuration column, we read an important change, since all benchmarks now extend to 30 full seconds long. We continued the vertical reading in the latency zone, noting that average delay rises more than before under sustained stress. Following the flow, we read requests per thread, showing lower individual performance compared to tests of shorter duration. The consecutive column shows global results, recording a much higher total request volume as it accumulates more active time. We now pass to the vertical block of socket errors, seeing that timeout failures appear earlier and rise up to 109. Moving to the right, we read the general graph, comparing how the mean latency curve spikes faster toward the far right edge. In that same graph, we observe the lower transfer line, which shows a clear drop in data sending under the maximum heavy load. Finally, we evaluate the key conclusions box, noting that the system becomes completely saturated when sustaining the traffic. With this, we finish running the server stress tests. We turn off the computer to give the final conclusions of the testing. In 10 seconds, the peak was 1141 requests per second with 12 threads and 300 connections. At 500 connections, timeouts appeared. In 30 seconds, the best mark was 12 under 4 requests per second using 12 threads and 300 connections, keeping a minimal error rate. Tests with 16 threads and 500 connections showed saturation, over 500 milliseconds of average latency, and up to 109 timeout errors. That is all for this video. If you liked it, please subscribe, leave a like, and turn on notifications. See you next video.